So, for example, if you're Qantas, you might only have certain rights to actually land at certain airports. So again, making a restricted value list rather than the superset of all different airports is probably what you're looking for, and then you can just define that list and choose that from your master data, for example. You can also use patterns to differentiate similar utterances and pre-built entity components. So there's lots of examples of food, location, various things that you can use out of the box. And then, of course, with this, you would just train, test, and publish just like you would any other model, except there's less to do when you're doing it completely from scratch. So you're not choosing the model, for example. You can just automatically already have that language understanding NLP process behind the scenes. And then the last thing there is to describe the AI language understanding features. So we'll have a look at some of the features that you can get out of the box there. Okay, so it usually would start from some sort of channel, your conversation, and that might be something like Teams. So a lot of people tended to put their first sort of like question and answer robots or chatbots inside of Teams. So that will help the majority of people, because I'd say everybody is actually on Teams there. So you can go and, of all the customers that have Teams, that is, there's other things as well. But if you're using Teams, a lot of people are, so you would possibly use that as your channel. But you can use lots of other channels as well. You can also use plugins, of course. So plugins have become very popular. Take something you already have and then add, extend it. So extensibility there, using that sort of option to do that. The large language model is used to determine semantic meaning. So the language model, not large language model, this is just a natural language model, works out what the user wants to do. So we see a lot of semantic meaning these days in large language models, so everyone's talking about that. And the app performs an appropriate action. So that's where it go and determine that. It will give a confidence score of which intent it thinks it is, and then it will basically, in the code, you'll have intents mapped to basically functions, and that function will be called in your application. So it requires a language model to interpret the user's input. You do need that natural language. Otherwise, you're going to be back to rule-based, and you'll say, if the person says hello, then say hi, so it's all going to be very hard-coded. That's why you still need natural language processing, and often referred to as natural language understanding in this particular activity. And then you can build out an end-to-end conversation there. So these are a couple of good examples here of utterances. We can do it as an example if you like. So maybe as a demo we'll do that. So we'll see what some of them are first, then we'll go and do that. So specify the utterances that represent expected natural language input, and then you'll map those to the intent. So you can see those first two there, I get time, the second two, I get weather, next one is turn on device, and hello is the none example. So the none example is where it drops out, where it's sort of like that chit-chat that you had in the Q&A, where it's just basically hello, goodbye, those sorts of things. And you can actually see this. One of the things behind the scenes with Copilot is you can actually go and have a look at this. I'll show you how similar they are in the same way that it's structured, because originally we had two tools that you would install locally. One was Emulator, so that you could test out your chatbot, and the other was Composer, which allowed you to use low code, drag and drop onto a canvas. If this happens, then do this. If this happens, then do that. So you could actually develop your whole composer with that. Now that's actually been replaced with Copilot. So Copilot Studio, while it isn't outlined in the course and you may not get any questions on it, you'll actually see a lot of similarities in the way Copilot Studio works. So when we go into Copilot Studio for the first time, you'll actually see that there are some Copilot chatbots that I'd already set up before. Not sure how, actually, because I've got a rolling sort of trial for this, I might have actually removed them, but here is the co-pilots here. If I kind of have a look at one of them, for example, this insurance standard docs. I think I did this when I was talking to one of the banks, and just a quick see what could be done. So if you come over here, you'll actually see that a lot of what happens in language understanding is happening here as well. So you'll see these actions. Pardon me, actually not the actions, the topics. So these topics are very similar to the intents, and you can see in a standard chatbot, the default that gets generated is actually hello and goodbye, start over, and then there are specific lessons or specific actions you want to take in there, or specific topics. So even when you're talking to it, you can see in this example, hello, I'm a co-pilot insurance standard docs. It's a bit of a mouthful, a virtual assistant. You can just ask it things like this. So it's going to still do, the interface looks very similar. The interface for all these chatbots is very plain, just about searching really. And it will answer with some sort of question that is basically a response. But of course, in this example, rather than just a couple of just one response, you can actually chat with it with Copilot in a more fluid sort of way. But that's actually what it looks like behind the scenes. You set up your knowledge base, so that's sort of like your RAG model that you bring in, so the data that you want. You have your topics, they're your intents, and then you have actions based on that. So if you want to do something like go and add a row to Excel, or if you want to go and send an email or something like that, you can hook in with the Power Apps sort of actions, and then you can also post it to various channels as well. So in a way, language understanding is very similar to the concepts that they use for Copilot Studio, but with a twist. These are actually large language models here, but a lot of that information actually can be used in conjunction with the sort of agents that they're talking about, including in that. So you can have a bit of hard coding for intents, where it goes down a certain path of logic, and other things that are more conversational as well. So here are the intents and the utterances that we've mapped. And then once we do that, we've got to go and find in the utterance an example of the entities. So in this case, London is actually one of the, reference data that we might have of all the locations where we particularly sell, for example, insurance, travel insurance. There might be embargoes on certain areas as well. And you can see also there's another one there about when. So that one's a times entity. And then you can also see location and time combined in there. So you've got a couple of different entities. There's a good example there where we've defined a set of devices. So it might be TV, light, fan, watering system, whatever it is. You can basically then have an intent with that on turn on the device. And the entities can be machine learned, like I said, or they could be pre-built, because there's a lot of ones you might want to just take out of the box as well. But of course, you might want to have your own, and you could also do regex expressions on that as well to work out what the entity is. So there are some cases where you might be asking a question in there, which is pretty much a title of a movie or an authored novel, so the title of any of those. It might get a little bit confused when you're asking the question versus what is the title. Now, large language models don't have that same issue, but the natural language processing does get confused between those sorts of things. So that is worth mentioning. Here's some pre-built entities that we talked about. Quantities, for example, date, time, email, phone numbers and URL. And of course, you can mask these, anything that you need to mask as well in these circumstances. So basically, I'm just seeing if there was any other things. Pattern.any is a variable length placeholder that's used only in pattern template utterances to mark where the entity begins and ends. So again, that's using things like regex to find that, or you can use this option for pattern any as well. So let's have a quick look at it and go in. And any questions so far that come up? Should ask that more often. All right, so let's have a look at the language understanding. So we're just in Copilot there. I'm just going to go into the language studio and use that service I had before. And let's see if we can find that one on the list. So of course we had lots of cool options here. So I'm just going to go to the question and conversational language, and then I'm going to go see how it's even referring back to Lewis as the next generation of Lewis. So actually let's ask it, why is conversational language understanding in the Azure AI Language Studio considered to be next generation of Lewis? So what have they done behind the scenes? What is behind the scenes to give it a bit of an upgrade? Now, I know Lewis has gone through a few iterations anyway. There was a few different versions of that. So let's see. So uses advanced transformer. So there you go. We're starting to now move into the realms. And this was one of the questions. I think it was, I don't think he's on the call at the moment. So yesterday we had a good question about what is evolving in the language space, what is evolving in the AI space, the traditional AI space, versus what we had previously, which was the natural language. So it looks like we're moving more to the transformer for some of the existing ones, like this next generation of Lewis. And of course, the one right next to it is the Q&A maker. So I assume it's gone, had an overhaul as well, going from natural language understanding and processing to actually go now into the transformer space. So that's pretty cool. We're seeing some progress there in the older things as well. Now, because we're grounding this one with our, RAG, bringing our own data, then that one's going to perform really well. So it'll be interesting to see how conversational language is a little bit different now. So first port of call is to go and create a project. So we're going to say Lewis 2, maybe 2.0, and we'll go for English. Enable multiple languages in this project. Now we'll leave it at that. And this is going to projects for home sort of thing. So it might be a home system that's actually looking after everything that there is in the home to turn on the lights and all that sort of thing. But we'll put a few generic questions in there as well. Okay, so the first thing that you see is your none intent. So how are you going to map that to utterances? If we come in here, all we really need to do is select none. Then we basically, even though we clicked on none already, a little bit of a user interface issue, we can just say things like hello, hit enter. So this user interface, it always impressed me. The interface has changed a couple of times since I started using it, and I looked at various cloud providers. Now, this was quite a few years ago. I looked at IBM, the Google one, and the Microsoft one, and even then, even before I worked for Microsoft, I was impressed by how easy it is to use this interface, because then once you get rolling, and you can do this in a bulk fashion as well, you can actually start to, sorry about that, it's always trying to help you, but unfortunately, when you've already seen it before, I should have said skip all. It's a little bit annoying when it does things like that. So, some other things. How are you? So these could be the none intents. It could even have goodbye in there as well. So you can use that none intent for a couple of different options there. So I put in a few. It doesn't take very long to put those in. And then I'm going to go back and create some more intents. So let's go back I'm just going to leave that. Oh, I did save it. Sorry about that. So let's add a couple of intents here. So turn on device and intent. Turn off device. So that's all we really need to do. And then we could have had some other ones you might have in, so this would be in a different bot, but then you could say buy insurance, for example, and then you can have whatever you need to be able to do. So you can make this really good home system to do everything basically. So if I want to put some entities in for that, I can actually enter some entities. So our entity name would be device, and then we can go and make a list out of that. So let's add the entity, and then we can go and add some things to the list. So we can also go and pick from pre-built. Have we got any pre-builts that we might want to use? No, they're those standard ones we looked at before. So I don't think there's anything to do with home automation. Probably should be. Temperature URL, no, there's none there. So let's add our own list. So there's that regex I talked about before. You can add the list. So in this case, we would say lights, and this is the one that always I get stuck on. Right, okay, lights. So you can actually put synonyms in for it as well. So let's say light bulb. Sometimes we actually, when we've got one at home, we say reading, if it's the reading light, for example, we do ask it to turn on specifically the reading light, which is next to me in the evening. Light, maybe even plural. I don't think you have to really worry too much about that. But also brightness, something like that. That could mean something else, although I just spelt it wrong. So let's save that. And then we'll add another one. So TV, television. Bring that to me again, television. And then TV might be a good option for that, or telly. Depends how you tell them. Okay, so we've got a couple of things. We've got lights and telly there, and we're going to save that as well. So we've built a little bit of an entity there. I might want to build another entity, but let's go back to, this was all about device. So let's go to the next option here. And now we will start to select our intent. That and put device in there. So turn on lamp, that could be another example. That's going to be a device. Another one that's device, and lights on, it could be something like that. Maybe clap. That sounds a bit hard to do. I don't even know how you would do that. So device, so we've got a few different utterances there, and they've actually even gone to the option now to actually have the difference between a training set and a testing set. So typically speaking, this is new. They only used to have training set in here. If you're adding a testing set, it usually means that you've got a bit of a fear around over fitting for your training set, so that it can only answer those questions, and it's a bit dumb and it can't do any more than that. So you add this idea of the testing set, you split the examples, make sure they're quite runs to see what he was getting overfitting, whether you need to adjust something, whether you need to add more data or tune your model. But at some point they're just doing a little bit of tuning there, not a huge amount, but this is not something we used to have. So we can do that one there. light on. So let's do that, and we'll use, I haven't used basically lights then. I've used something different there. So I'm not going to worry too much about the accuracy of this one. Let's save the changes. And then we could have, for example, turn off the light, but we'll come back and see what happens now. So let's go into here and start training. Now, a lot of these have, for example, I remember I was saying before in custom vision, you have two options. One is standard, one is advanced. The main difference is one's more costly, takes longer. The standard training is free and, it's pretty quick. So that's what we'll start with, and of course you're going to get better results as you do more advanced training. So it's spending a lot more time tuning and behind the scenes. So let's home automation, and let's go standard training, and then you've got an example there of the testing and training. So it'll automatically spit because we have the data there, which is interesting because I'm thinking, why didn't we just create it all as one big bit and then it worked it out? But you can actually tell it what is the percentage of training, what is the percentage of testing of the data that you're going to use, which is kind of doesn't make sense anymore because they actually split them up already. So that's a bit weird. Not sure why they've done it that way. It doesn't make sense to me. You'd either do that, you'd either just have one data set and then split it before you train, or you would actually not ask this question now and put, of the data set you're going to create, 80% of the data on one and 20 on the other. So I'm not quite sure why they've done that. Maybe they're concerned about unbalanced data sets, and mine definitely is one example of that. It's got hardly any data there. So let's go for training. So that's a relatively new feature there. And you can see it's going into the queue and it's complete. So it is very fast, and unfortunately, that's where its downfall is. It's usually a bit too fast. So now that we've got that, we can go and have a little bit of a look around. I didn't have a lot of data there, so I can go and have a look at the performance as well. So it hasn't given me a lot of data, and that's because I didn't put a lot of data in. But let's go into, we can go and deploy that then. So we can deploy that one, and you'll replace, for example, what's in production. Create a deployment name, James Auto Deploy, and then we will use that model, and we will select a region to put that in. So that's now deployed, so it can be used. But let's give it a test. I mean, that's the putting the cart before the horse for sure, because I haven't even tested it out yet. So let's see how it goes with the testing. So try out a few different options when you're doing this lab. I'm just making stuff up as I go. And you can see this example here. If you want to test it out, enter your own text. So turn on the fan, because we didn't have that as an example, and it doesn't look like it's doing anything. So I haven't really been able to test that. I'll run the test, sorry. I missed the button. Up the top is always a little bit strange. So there you can see the result. It got it right. It wasn't particularly high in the confidence score, so it did say that the fan is a device, which is good, and that there it is with the fan outlined in the as the entity in the utterance there. So it did okay. You can also see it in JSON format there as well. So that's basically it, just a little bit of a demo. To go back and improve, I would add more data, and I would also go and train it for a lot longer. But I don't want to train it now because it probably takes about an hour to train properly. But you get the idea of what you're trying to do. One thing I didn't see here was in the testing, I didn't see a spot in here to actually correct it. So it looks like it has changed, the new version has changed quite a bit, and you don't actually get that option as well. So with new Lewis, we'll call it, how come I cannot correct the intent see that anywhere along the way. So let's see whether it's possible. In the new conversational Lewis service, which is scheduled to Lewis, the ability to directly correct the chosen intent not be as straightforward as in Lewis. Here are a few examples. So they're talking about retraining the model. So again, it's more about a bit of a hard slog there, although this is performing a lot better than Lewis, like a lot quicker. So you'll get a turnaround a lot quicker. With direct correction while direct correction isn't available, when the model selects the wrong intent, you can log this feedback and use it to retrain the model. So there you go. You can actually improve it over time, like you did with Copilot. I don't know whether you can do that, but yeah, anyway, that's interesting. So if I go back in here and just have a look at what it's talking about, intents, there you go. So Lewis will retire next year in October, and starting the 1st, we've got the new Lewis. So that's actually been out for a while, but I didn't realise that they're actually using the new transformers for that. So that's interesting. All right, so I think it's your turn now. What were you going to say, Terry?
Okay, I have like a couple of questions. One is that so while you're training the model, there's lots of manual effort. You go to the UI, you add the string, you add the, you know, these are the devices in my entire strings or something like that. Is there a way to do this activity?
Yeah, so the upload is possible there. So you can upload your intents and your utterances, and then you can do suggest utterances as well. So it's using Copilot there to suggest some examples there. So you've got some options. You always had an option to import some of these things if you wanted to, rather than use the interface. But yes, so
Can we output this as a file to see how the output looks like? Which format
I think maybe the move to, but it looks to be greyed out at the moment. I don't actually have, let's accept all. So I didn't actually tell it to say that these are all okay. So accept all. I think, yeah, that's actually, it's done. But I haven't really used the file for that. So learn about the format. There's an example there where they've got, I left my heart in Alexandria, Egypt. It sounds like San Francisco, but there you can see it's got the entity that it's worked out, which is the city name and where that's starting. So that one's actually got the utterance examples that you can upload and suggest utterances. Let's see, this feature is not supported in the resource, so maybe we try East US if we want to do that. And it looks like you can use Azure OpenAI to suggest different options, but I'm not quite sure behind the scenes, just seeing if there's other information there. So not quite sure how you would you can transport these, because I've seen people do that before, especially when we had pre-canned examples. We used to import that, so I'm just not 100% sure where you can do that. So I'll see if I can find some more content there on automation. But you can see there that there are some options to automate already. See if there's any others as well. All right, any other question?
Yeah, the next thing is that so you mentioned like turn on the device. So it's like static string. If you change that context while doing that, will it still work?
Yeah, it's not a static string. It's going to use natural language understanding to see what's similar there. So these are just suggested, maybe 5 to 10 suggested ways of saying something, and then it will work out pretty close to what you're actually asking for. So it does a very good job, and even the older version did a very good job of working out what intent you're actually trying to achieve.
Yeah. So is like Azure AI also helping to train the model? Like for example, if I put other than like devices like fan or lights, or those are we are saying recommending them as a device. And if you say car, it will pick up like yes, car is a device.
No, because I didn't use machine learning entity. I used a static list, but I could have used machine learning entity instead, and then it could have worked out that a car is similar to a light, for example, as some sort of device in the home. Yeah. So it could be like warm up the Tesla out the front.
Okay.
Something like that. Yeah, but in my case, I kind of prefer to sometimes have control over things like that, especially in a closed system like this, where you need code behind the scenes to do each one of these quite differently. Turning on the light and turning on the pool pool light are very different applications, I suppose, for the home automation. One is going to, monitoring for the pool, so it might be like, a brand of product that you're actually calling. You're calling an API into that, and then the other one is calling a different type of, function altogether in the house. So those two things aren't equivalent. The turning on the light in the pool versus turning on the light out the back even are a little bit different. What would happen behind the scenes? So I think in this case you're going for more precise with home automation, but with some of the other ones, like if someone's using a chatbot online, then you'd want to have machine learning because they could say just about anything, but you still want them to be able to book a reservation, which is probably in that case a very one-sided, not too many different functions that you need to call, whereas home automation is quite broad. So yeah, I think it just depends on your use case as well. Yeah. Anything else? Good questions there, Trinda. Right, so it's pretty cool. So have fun with that one. That's lots of fun to set up. I actually quite find that quite enjoyable to do that. I kept it short, but I usually put too much in there. I am mindful that custom vision still don't work from yesterday and the key vault. So I'll continue to work on those two issues, and I'll try to get some more automation tips for Lewis as well to reduce that. What else have we got there? So pre-configured features can be used without labeling or training. So there are some things that you can use in there that you don't necessarily have to do that training on, like we were doing there. So key phrase detection, sentiment analysis, all those existing things already pre-configured, but some of the learned ones include the entity recognition. Of course, we had a bad time with Mars, for example. It didn't know what we were talking about when we were trying to get it to talk about the chocolate bar. So that could be a good example where we want to make that a better use case. So this is where we could train it to do custom text classification, question and answers, the language understanding, and that entity recognition before as well. So this is just a bit of a summary of what we're able to do. Okay, so processing predictions there, you can see in this example that the intent comes back with the confidence score of that. And if you're getting a very low score like we did when we just did the quick training, then we might want to improve that by doing the long training, and also by tuning that. So it mentioned you can't correct it, so a bit of a tuning there in more questions, for example, would probably be the answer to that. So more examples of utterances. Submit a request to a published slot. So this is talking about production in particular. So you will have different models in different slots, I suppose what that's talking about. And it indicates which language feature you're requesting. So if you're requesting production and you're requesting in particular conversation there to get time, then it's able to work out also whether you're trying to do conversation versus entity recognition. The parameters, so you could have various input parameters as well. So maybe you have to go and get some examples of that. So let me do that as well. So parameters for the slot. Sorry, I didn't have an example of that. Didn't notice that one this morning. And we've got analysis input, so specifies the input documents. So that's all about what's coming in that you could then basically work out. So some of the parameters might include, I want to also see the location of that, but I'll see if I can get a more comprehensive list there for you as well. So that's pretty much what we sort of did. We did the training, testing, publishing, and review. We didn't really put a lot of effort in testing, and that's pretty much that idea of the custom, sort of being a data scientist, a citizen data scientist there when you're doing that. Deploying a trained model and then reviewing the predictions and iterating on utterances there to train your model. So again, this is always improving, so you need to be able to retrain it on a regular basis with more data. Okay, so let's have a look at the next one there before we do our lab, and that's custom classification named entity extraction. I thought we were actually going to the lab and then we didn't, so, and it's 2 o'clock, so I'm a bit mindful that we might be running out of time with this. We're over halfway of the day and we're over halfway of the content, so fingers crossed. All right, let's have a look at labelling documents, training and deploying models for custom classification. We'll have a look at understanding model performance to improve the model and also using custom model in an app. So here's an example here where we're using custom text classification with a whole lot of articles, and you can see they're labelled straight away with what type of article they are, whether it's sports, news, entertainment, and you can see whether that's a training or a testing data set there. So you go and label your documents and then you go and train your model. You can call the model through the language API and specify the project and deployment name. And then you can have a single label or multi-label project as well. So you can see in these cases you can add a class, a new class, and then you can also have various versions of sport. So it could be women's and men's sport, for example, just depending on what you're looking at. And there's a good example of what that's going to look like when you set up the labelling. There's the named entity recognition. So in this case, they've picked up Seattle and San Francisco and actually labelled that in each of the content as well. So that's what you're going to do. I won't worry too much about going through that one now, because when we do documents on Thursday, it's a very similar idea. You go through and you label where certain parts are. So you pick out the name. In this case, we're picking out the city, and whether we've got a team name there, for example, that actually might have been the whole thing, might have been team name. So that's actually a really easy way to go and add the labels and then basically go and find them in the document itself. So that's all part of setting up your data for training so that it is supervised as opposed to unsupervised. So reviewing and improving, what you'll get here is an F1 score, precision and recall. Of course, recall is used to look for bias and things like that. So just depending on what your training comes back as, you should get some information about how well it has performed. And based on that, you might decide to broaden the diversity of the data there, because maybe it's not fair or the predictions aren't coming back fair. So, sorry about that, the cat's going off a bit. So you can go and review the performance, and you can also look at a confusion matrix. So if you haven't seen the confusion matrix before, I suppose it usually looks a bit like this. I alluded to it a little bit earlier when we talked about responsible AI. So that's usually what it looks like. You've got predicted up here, and you've got, and then you've got your actual value there. So that's using data that's already labelled so that you know what the outcome is meant to be. And if, for example, you predicted O, or if you predicted 1, for example, if it was a binary classification, so the 0 or 1, 2 class, maybe using 2 class logistic or whatever it is. So predicted versus actual. What you'll have is based on all of the data that you have a number in each one of those. This one is going to be the true positives. So you might have a number out of 1,000 records, 100 were considered true positives. Out of 1,000 records, you might have 200 were considered true negatives. And then if you predicted 1 and it was actually 0, then that's going to be a false. That's going to be a false negative. False positive, because you're predicting 1, but it should have been 0. And by the process of elimination, the last one is false negative. So you might have, for example, 300 in here, 400 in here, and then that's going to make up your distribution of data. And that's what usually this would bring. For example, if you did certain calculations for recall and precision, an F1 score, you can use the values that are in here to work that out. So it does that behind the scenes, and it's saying learn more, so I think you can actually go and have a look at the confusion matrix, because it does say that there's an output there of confusion matrix. So that's where I usually go back to have a look at Wikipedia whenever I get stuck forgetting what those formulas are, which I just don't keep those formulas in my mind, for example. So wiki recall and precision and confusion matrix, I usually just search for something like that. And then there should be a Wikipedia page looking at the confusion matrix. And they might have this slight difference. So predicted might be along the left, actual might be across the top, the 0 and the 1s might be the wrong way around, or there could be more multi-class, for example, so you might have more in there. So here's an example of the way that they've done it, predicted across the top, actual, so they've got similar to me, but I've put these around a different way. So that's where you'll actually have true positives up in the top here. So mine were down in the bottom, no big deal, just the way that I've drawn it. And there's a good example of when we need to be very careful is in this false negative area for things like cancer and things like that. It's going to be really, really tricky to make sure you get that right. And there you go. You can actually see that it's got a couple of formulas there. And if you go and have a look at recall on that page, hopefully, there you go. So it's true positives over the number of positives, which was the total number of positives, is equal to 1 minus FNR. So it just depends what you're looking at. False negative rate is what that one's talking about there. So that will tell you behind the scenes how to calculate these things. But of course, the machine will do it for you anyway and give you totals and also the scores. I don't know whether the F1 score is in here. Let's have a look. It might. Yeah, there you go. There's the F1 score, and then you can go and find out more about the F1 score as well and how that's calculated on the distribution of data. So that's basically all this sort of content. And then you can retrain your model with new data if you feel that you're not getting the right results here. You'd also change the sensitivity of this model so that you things fit into different compartments, because when you have a look at these false negatives and false positives, there may be a huge amount of legwork in here for people to go in, the human in the loop, to try and work out whether all these are really, performing correctly or not, or classifying them correctly or not. So there's quite a lot of work there associated with that, like manual work. All right, let's have a look at the last one for the day. So you'll actually be going and doing this one as well. So speech recognition and translation. So changing gears quite a bit. So whether it's speech to text, any questions so far on any of that stats, or this is a tricky area. We don't spend a huge amount of time usually doing confusion matrix, but I thought, because this is AI as opposed to data science, might just put a little bit of information there together. All right, so we'll have a look at the synthesis markup language. I want to say markdown. We'll have a look at AI speech, and also using audio format. This is audio format for output or input, and then voices for different types of the neural version of this, where you have lots of different nuances with the way they speak. Again, speaking, it's pretty much sounds pretty much like a human these days. You also notice in Copilot, they've added this in the new version of Copilot, which was out a couple of weeks ago, for using with Edge browsers and things like that. It doesn't really matter where you use it. But the Copilot actually had a few different voices you can choose, and you can save a lot more information now. So it's gone to the next level. So that's pretty cool as well, but pretty much in line with what our other AI services are doing as well. So there you go, speech recognition, synthesis. We've got the API call for recognition and translation, and also the intent. So using conversational language, so using Lewis again there, or probably transformers. So in this case, you can see it can produce either documents or output to indicate what's going on with all the metadata and whatever you're trying to do. Plus, you can also respond in audio there. So again, we're seeing Copilot being used with microphones now, and it's a lot more conversational then. Here's an example of speech to text. So we take a couple of different pieces of information in there. We have the microphone default file, is the default, or you can have a file, say some sort of WAV file. That's your audio configuration, and then you've got your speech configuration, which is made up of your key and your location of where your resource, your service is. And then you have an asynchronous call to, using speech recognizer, and returned are things like the duration of the speech, offset in ticks. So where does it start from? Where do certain parts start from? Properties of this, and also things like reason. So you've got some good examples there. Recognised speech, you can have no match or cancelled. So I wonder whether I might have those on a later slide. Duration, the most important being duration, reason. So no match means that the call succeeded, strangely enough, but no speech was detected. So that's a bit of a fail anyway. Cancelled usually means something went wrong. Otherwise, there's recognised speech in there. So if you have recognised speech as a result, you will get this text field actually filled in with the transcribed recognised speech. So again, you can use lots of different languages there. Same with speech to text, everything's pretty similar. You've got the resource location and key. What sort of speaker that you want to produce this? So there's a default there. Or the file, you can explicitly use null to retrieve a stream object there. So again, this is going to the speech synthesizer and returning a value asynchronously of the audio data, the properties, the reason, and the result. So you get an audio stream out of that one. So there's two, text-to-speech and batch synthesis. So for your bigger data, you're looking at the batch version. For text-to-speech, just a smaller sort of content there. So the audio data there is audio stream redirected to a file or speaker. So speaker is not the speaker that I talked about. Sorry about that. A bit of a mistake there I made. Audio formats and voices. So you can have different types of audio format. So the sample rate and bit depth is actually included in the type of format that you want. And then the voices. So like I said before, there is this concept of having some standard voices, and then there's more nuanced, sort of natural sounding neural voices, so using a neural net behind the scenes. So that's the big difference there. You can see this example where they're using English George, so Great Britain George, so he's going to have a very proper English accent. You can also see some of the samples there with the sample rate, for example, and the audio file type is all included in that format there. The bit depth, I think, is also in there. Jeremy, sorry about that.
What if the two person are doing conversation and they both are using different language? So that scenario, what will happen? So let's say one person is speaking Russian and one is in Chinese. How will that audio file convert into text or vice versa?
You would have to convert that first to translate first. I think you can translate it, and then you might have a second step in there to translate after the fact, or before it. So you might have to translate it first before you can do that. So I'll see if I can find some examples of that one during it as well.
It's hard, right? How to do with the conversation going continuously with two persons. You need to pause and then translate.
Yeah, it won't be possible in real time on. So translation and text to speech as well. See if I can find some examples of that. So it's getting better all the time, but I don't think we're still looking at asynchronous translation at the moment still. Although when you look at the large language models and some of the demos they did of Gemini and Omni for ChatGPT, they were pretty good. But we've also seen some examples where they were using the robot. I'm just trying to think what that example was. That was actually cut. That was edited to make it look like it was quicker response time as well. But it was still pretty good. It was just, they just took out all the lag times. But yeah, I think that's an interesting one for conversions as well. I would have thought would be slow, but it's getting faster all the time. So who am I to say? All right, I'll see if I can get some more information on that. XML-based language with customization options. So this is only using the neural voices. You've also got the speaking style is going to be even more precise. So it's going to sound more like a human, and you can use pauses, silence, phonetic pronunciations, speaking pitch and range and rate. And then if you've got a number, rather than just going blah, 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 it'll actually say it as a number, so it'll sound a lot more natural than when it's just, I'm connected to blah, 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 blah. That's usually what it does on my headphones. Insert recorded speech or background audio as well, so that's pretty cool. There's an example of phonetic there with tomato, and you can see you've got a break there, I think, is it? Oh, break strength. So you've got to pause, and that's got the whole thing off. So, I say tomato, you say tomato, if you remember that saying there. You can see also they're using Neural there, Aria and Guy, both US voices there. All right, so just see how we're going for time. Make sure you have enough time for your labs. So translation of speech to text. So we've got the location of all the information associated with the service, the language type that's going to be used. So you note there's no translation during that either. It's just speech to text. So you can't see this option of having different languages anyway. So I don't know whether it's possible. And the input for that is going to be, again, the microphone. So you've got this speech translation config, which is all about service, and then the actual thing that you're trying to translate, which is the audio config. Again, it's an asynchronous call. It has very similar things again, and you've got a transcript of the recognised speech there. So with target language as the key there as well. So that's an interesting one. Recognise and transcribe spoken English in speech recognition language, return translations for one or more. Although, there you go. So that one's actually one or more target languages. So you're right there, Trinity. It is possible to be able to do that in not real time. It's still asynchronous, but it is possible. So that's good. Example of it there. And the other thing you can do is event-based synthesis. So specify a desired voice and use the synthesizing event to retrieve audio stream. So supported for one-on-one translations just to a single target language. Use the synthesizing event to retrieve audio stream. Create an event handler, and then you go and get the audio to retrieve the byte stream. Or you can use it as manual, so use it for multiple, that's one of the advantages there, and then translate to use the text-to-speech API. Okay, so that is a little bit about speech-to-text, text-to-speech, bit of translation in there as well from different languages. So I'll see if I can find you a little bit more on that. Any questions other than what we've had so far? So I think you're at liberty to do labs for the rest of the day. So we're almost at 2:30, so I think probably it's time for a break before we go into the labs. Do anyone have any questions before? We'll wrap up the content for the day like we did yesterday, so people in the US can drop a little earlier, and then they can come back and do the labs in the morning. So any other questions while everyone's still here? Might help the people. All right. It's good we get questions while we're doing the content, which is really the best way to actually get it when we have it as we're going. Because it makes more sense. You've got to go, oh, what was I talking about when I talked about that? Okay, so let's have a look at creating intents and entities, and then straight after that go into the recognise and synthesise speech. So you've got a few options there to do for your lab. Let's have a quick look. And these are the two that we're going to be doing for the rest of the day. So lab 7 and 8, my numbers are different, so you can see 7 and 8 there. Just ignore the numbers on the left-hand side, they don't mean anything. So labs on after the break. We're doing okay time-wise, and we will go to the break now. So have a quick 15. Come back and do labs up until 5. Unless you get bored and then you want to drop. But US people, you can drop now if you like, so we won't do any more. Promise not to do any more new content. All right, have fun at the break.